Good morning, students. Now, today we are going to discuss about class 11 physics, chapter 7, that is system of particles and rotational motion. System of particles and rotational motion. So, what is the flow of video lecture for part first? First of all, let us describe about the flow of lecture for part first. And the flow of lecture consists of the first thing is introduction for system of particles. System of particles. Then, second thing we will discuss about rigid body. Rigid body. After that, we will discuss about different types of motion of a body. In this different type of motion of the body, first we will discuss about translational motion. Translational motion. After that, pure rotational motion. The third one is precision. And fourth one is translational plus rotational. Translational plus rotational motion. Okay, so this is the flow of lecture for the part first for the system of particles and rotational motion. So let us introduce you about the system of particles. What is system of particles? Look here, students. Till now, we have discussed about point masses, and all of you are knowing about the point masses. Point masses are those masses. What are point masses? Point masses. Point masses. Point masses are what? Size of the mass, size of the object, size of the object is much smaller than the distance traveled by this is called point masses. Point masses means to say that if the size of the object is much smaller as compared to the distance traveled by the object. Suppose, for example, I am taking that, suppose you are a school bus of Divine Public School, and this school bus is moving from Mohanapur to Delhi, New Delhi. If that school bus is moving from Mohanapur to New Delhi, then as per the size of the bus, the distance covered by the bus is much larger. And for our calculation, in that case, we consider the bus as the point object or point mass. But if that bus is covering the distance from the principal chamber to the school gate, then in that case the bus is not considered as the point mass, it can be considered as the extended object. So we have discussed about the point mass. Now, then what is the system of particles and how point masses are related to the system of particles? So system of particles means to say that system of particles means to say that if the collection of point masses, it is system of particles is the collection of point masses, it is the collection of point masses. And which type of collection of point masses? Which type of collection of point masses means if the separation between the point masses does not vary with time. Does not vary. Separation between the point masses does not vary with time. Suppose I am taking an example. Suppose in this example there is an object. Then this object can be considered as the group, cluster or collection of different point masses. Suppose M1 is here, M2 is here, M3 is here, and M4 is here. Okay? Now, if this whole object is moving with velocity v, and if the separation between these two is r1, the separation between these two is r2, separation between these is r3. Now these are the separation between these point masses. Means if this object is moving with velocity v, then all the masses of which this object is constituted, these whole masses are moving with velocity v, and the separation between these two masses are not going to be changed. Or M2 M3, the separation between M2 M3 or M3 M4 is not going to be changed, and all the masses are moving with velocity v. Then this group of point masses can be considered as the system of masses. This group of object is called as system of masses, and these masses are called as particles. The small masses can be considered as particles. Means in this way the whole system is moving and the separation between the masses are not going to be changed. So this can be considered as masses, and the whole collection is called as system of masses. Clear, students? Now we will discuss about rigid body. What is rigid body? Look at here, the rigid body. This is introduction about system of masses. Now we will discuss about rigid body. Rigid body. Rigid body. Now, what is the rigid body? What is called as rigid body? As it is clear from the name, rigid body. Rigid body means to say that suppose we had taken the rod. We had taken the rod and here 2 points I have taken P1 and P2 and the separation is R. And if the forces are being applied in different type of forces, different forces are being applied on this rigid body, and after the application of forces also the separation between these 2 points are not going to be changed, then this is called as the rigid body. This is called as the rigid body. Means after application of force, the separation between the various points or various particles of the body is not going to be changed. Various particles of the body of which this object is being constituted, the separation between these is not going to be changed. Then in that case, this is called as rigid body. Then we had discussed about the system of particles. The same thing we had discussed about the system of particles. Means for the objects which are constituting system of for the objects which are constituting system of particles, for the objects which are constituting system of particles, the object should be a rigid body. The object should be a rigid body. The object should be a rigid body. Means if I am saying that suppose there is a rubber band. It is a rubber band. Suppose it is a rubber band. It is a rubber band, and here there is point P1 and here is point P2. These are the particles. These are the particles or constituent particles of the system. P1, P2, P3, P4. Okay. Now, if a force is being applied on this side, if a force is being applied on this side, and the separation between P1 and P2 is R, the separation between P1 and P2 is R, and if a force is being applied and it is rubber band, so it has the property to be stressed. It has the property to be stressed, and as the force is applied, means this distance R between these two constituent particles are going to be vary, and as the distance between these 2 points P1 and P2 is going to be vary, so it cannot be considered as a rigid body. It cannot be considered as a rigid body, because after the application of force, the separation between the points is going to be vary, and since it is not a rigid body, so it cannot be system of particles. 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 So, for a body to be acting as a system of particles, it is very much compulsory that it should be a rigid body. It should not be a flexible body, or the separation between its different constituent particles cannot be going to be varied in any condition. So this is about the system of particles and rigid body. If you want to define, you can say that a system of particles in which the separation separation between the particles are not going to vary with time is called a rigid body. That is called a rigid body. Means after application of force also the separation between the 2 points of the body is not going to be changed. Then that system of particle is considered as a rigid body. Now we have discussed about system of particles and rigid body. Now we are going to discuss about the different types of motion, different types of kinds of motion of a rigid body. So now from here, dear students, whenever we are talking about the body in rotational motion, if I am saying about the term body, if I am going to say about the term body, it means I am talking about the rigid body. I am talking about rigid body. And if I am talking about rigid body, then we can consider it as a system of particles. We can consider it as system of particles. Now, we are going to discuss about different kinds of motion of a rigid body. Different kinds of motion of a rigid body. Different kinds of motion of a different kinds of motion of a rigid body. Okay, means suppose a rigid body or a system of particle is moving, then it can execute different types of motion, and we will discuss that different type of motions, what are the different types of motions and what are the nature of the movement of the particles, constituent particle of the system of particle while the body is constituting the motion. So the first one is pure translational motion. The first one is pure translational motion. What is the pure translational motion? Suppose I am saying that this is an inclined plane. This is an inclined plane, and this chalk is moving like this. This chalk is moving like this. Without rolling, the chalk is just moving like this. Or you can say that if there is an inclined surface, suppose this is an inclined surface and an object is placed over it, and this object is moving with v velocity over this inclined plane, that is inclined plane ABC. Okay, this is inclined plane ABC, and an object O is moving in this way, and object O is moving in this way. Then this type of motion is called as pure translational motion. This is a system of particles, but the system of particles are moving on a straight path, on a rectilinear path, or we can see that if it is the object O and this object O is moving with velocity v on the then such type of motion is called as pure translational motion. Means the motion in which the system of particles are moving in a straight path. Suppose I am saying that these are the different constituent particles of this body, that all the particles are moving with velocity. All the particles are moving with velocity v along a straight path. All the particles are moving with velocity v with along the straight path. So such type of motion is called as pure translational motion. It is a pure translational motion, that is motion of the body on a straight path. Okay, this is about the pure translational motion. Now we will discuss about the pure rotational motion. Pure rotational motion. What is pure rotational motion? Pure rotational motion. Second one is pure rotational motion. What is the meaning of pure rotational motion? Dear students, you had studied about the circular motion. And in case of circular motion, any object is moving on a circular path. Then this type of motion is called as circular motion. This type of motion is called as circular motion. Okay. Now, how the circular motion is related? Why I am telling here the circular motion, and how this circular motion is related to the rotational motion? Pure rotational motion. How this circular motion is related? Suppose you are seeing the fan. This fan. And if I am going to switch on the fan, the rod of the fan is the axis of rotation. Means along this axis, there are three axes. There are three axes. That is x-axis, y-axis, and z-axis. And suppose there is a fan here. And these are the blades of the fan. These are the blades of the fan. And as I am switching on the fan, what will happen? These are the different particles of the system. These of the body. Rigid body. These are the different constituent particles of the system of the rigid body. Means as we are going to switch on the fan, about this axis, that is the axis of the rod, the fan is starting moving. And since the separation between the points are not going to change, so whatever the velocity of the body, all the particles, all the constituent particles of this body is also starts moving. All the constituent along a circular path. On what circular path? The rod is moving. All the constituent particles of this fan is also started moving along the circular path. And since when the motion of the body, when all the constituent particles of the rigid body is moving along a circular path, then such type of motion of the body is called as pure rotational motion. Such type of body is called as rotational motion. Another example I am telling you. This is R1, this is R2, this is R3. Okay, and suppose this is body, or this is the body, or you can say the system of particle, and this is the axis of rotation. This is axis of rotation. If this body is rotating around this axis, then suppose this is point P1, this is point P2, this is point P3, means all the particles starts rotating along this axis. All the particles starts rotating along this axis, making a circular path of radius R1, making a circular path of radius R2, and making a circular path of radius R3. Means if the different particles of the system of body is executing circular motion with a different radii, then that motion of the system of particle or rigid body is called as pure rotational motion. So this is the pure rotational motion about a fixed axis, This is pure rotational motion about a fixed axis. So you can define it as when the particles of the system are executing circular motion with different radii, then the motion of the body is called as rotational motion. Then that type of motion of the body is called as rotational motion. So this is about the pure rotational motion. Now the third one is the case in the rotational motion there is another type of motion. Apart from this pure rotational motion, there is another type of motion in which what will happen, one end of the axis is fixed and the other end, around the other end of the axis, the object is rotating and one end is fixed, and that is called as the precision. Just like the motion of the top. Have you used to play the top? Yes. In case of the playing top, what will you do? You wrap a string around the top and used to make you give the jerk to the top, and the one end of the top it is attached to the ground, that end is fixed to the ground, and the other end is rotating like this. So that type of motion is called as precision. So let us understand the precision. The third type of motion is precision. The third type of motion is precision. Precision. You had observed the motion of the top. Suppose this is the axis. Suppose this is the axis. And what you had done? This is the top. This is the top. And what will happen with the top? Okay? So you will see that this axis is fixed. This axis is fixed, and the top axis or the uppermost part of this top is doing a circular motion, and similarly the other parts in this way they are moving. So this type of motion is called as precision. This type of motion is called as precision. This is moving like this. This point is moving like this. This point is moving like this. These are the different points P1, P2, P3 for this system of the top. System of the top means one end of the axis is one end of the axis of rotation. Axis of rotation. Rotation is fixed. One end of the axis of rotation is fixed, and the top uppermost part is executing circular motion. Upper part is executing circular motion. So this type of motion is called as the precision. Now dear students, we will discuss the next type of motion. Next type of motion, that is the combination of translational motion and rotational motion. The combination of translational motion and rotational motion. So in precision, we can say that one end of the axis of rotation is fixed, and the other ends are moving in a circular path. Then such type of motion is called as precision. Now the next type of motion is the combination of translational and rotational motion. Dear students, I want to add here another point, that in case of pure rotational motion, the plane in which a particle of the system is moving is always perpendicular to the axis of always perpendicular to the axis of rotation. Axis of always perpendicular to the axis of rotation. Axis of rotation. And the second thing is the particles on the axis of rotation. The particles on the axis of rotation is always particles on the axis of rotation is always fixed. Suppose this is the axis of rotation, and an object is executing the circular motion, an object is executing the rotational motion, any body is executing the rotational motion, means this plane is always proportional. This is the plane. Suppose a particle is executing circular motion and the axis of rotation is this. So this plane is always perpendicular to this axis of rotation. And the second thing is that whatever the particles are on the axis of rotation, if this is P1, this is P2, these are the particles on the axis of rotation. So these particles always remains stationary. These particles remains stationary. This particles remains stationary. So these are the points about the rotational motion which you have to know. Now we will discuss about it. Now in the next video we will discuss about the pure translational motion and rotational motion, means the combination of these two motions we will discuss in the next video.